Alright. Okay, let's see here. Let's try to get this window minimized. And then... this one's an important one. This one lets me read the chat. So we'll go ahead and zoom that in. I am now live. As gloriously stated by Tobias in the chat, I am now live. And with that said, welcome to the stream, everybody. I have a few announcements I want to make just before we get into this. First thing is, I know that I didn't do a live stream last week. I announced this on the Discord server, but last week I actually got my first Pfizer vaccine, and I was a little out of it for those few days leading into when I would usually do the stream. I'm happy to say that it went well. I didn't have any major side effects from the vaccine. I didn't die or anything. I'm very much still alive. Very much feeling great. I'm gonna be getting my second dose in a few months, so I'm excited for that. Hopefully we'll be able to get a lot of people vaccinated and get this world back to what it was before COVID existed. I'm excited. But that's why I didn't do the stream last week, and I also haven't been making many videos this week and the last week. Last week for the same reason I mentioned earlier, with the vaccine and all, but this week is because I've been working on really what we're going to be working on in this stream, which is porting Thundershock engine to OpenGL, and soon DirectX and Vulkan, instead of using monogame. See, the thing with Thundershock engine is it's based on an earlier engine I wrote, more of a framework actually, called Pandemic Framework. I started working on it during the pandemic, which is why it's named that. I stopped developing Pandemic Framework in late 2020 because I just got burned out of programming in general. But then I started working on Thundershock engine because I really needed a game engine that is tailored to my development style. See, there is Unity, and it's great and all, but there are some things that I don't like about it. It's not very accessible to me. I mean, I can get away with using it, but it's not my type of engine. There's Unreal, which has a lot of great features that make my development life a little easier, but it's very, very demanding on the system. It's very bloated. Exporting a basic build of the PeaceNet back in the day was like half a gigabyte. Most of that was dedicated to the engine, so it has great features, but it's very bloaty. So really, I needed a game engine that is lightweight and has the features from Unity and from Unreal that I like, but none of the stuff I don't like or don't need. That's what Thundershock engine ultimately is. It's my dream game engine. For the longest time, though, it has been based on monogame, because that's just what I use for building these custom graphical applications in .NET. Because I like using C#, I have my engine written in C#. I'm just gonna go ahead and turn Monster Cat down a little. It's a little distracting. I'm gonna turn it back up soon, but... the problem with Thundershock engine is it still uses monogame. And there are some things with monogame that really are not great. And even the monogame devs know this. Content Builder is awful. It's there for legacy purposes, for XNA compatibility. That way you can take your XNA game, take all your assets, and get it working in monogame. And the idea is that later on you find a better way to load assets in. You're not really supposed to use Content Pipeline for production. It's not a great environment. Problem is for shaders and things like that, you kinda need it. I mean, the Content Pipeline is the shader compiler, so that's not great. But there are other issues with it, like just the general way the API works, is great for small games, but then there are certain limitations with it. For example, with text rendering, if you want to use sprite font, you have to use sprite batch. You just have to. I mean, there are ways around that, but it's... you basically have to reinvent the wheel. You can't just render a sprite font with your own custom renderer. You need to basically rewrite sprite batch, which is not great. And there are a lot of other issues like that. So, the goal of this Thundershock engine revamp is to totally get rid of those issues, and have an engine that works exactly how I want it to. And maybe you can make your own games in it, who knows, but it's gonna be primarily my dream game framework. And it's already sort of coming together. I'm looking at the Red Team source code right now that you guys don't really get to see. And if I run it, that was the wrong window. I was focused on the hat and I just refreshed it. Oh well. If I run Red Team, it does actually compile, and it does run. Now this is a new feature coming into Thundershock, the pack system. It's not fully working right now, but it does yell at you every time you launch the game saying, hey, you're missing your engine pack. Don't worry. Just ignore it. But yeah, we've got a game window. It's in broadcaster mode, which is why it's delaying a little bit. But hey, there's the bloom shader. Sound effects are working. And we're in the main menu. There's the announcement dialogue that I've been working on. And this is Red Team. Alright. Now, watch this. I know you guys are pretty active in the chat right now, even though I haven't really officially started the stream. This is how I did it in the Little Big Planet videos. I can show you now. If I right-click on this, I hit read aloud, you're gonna hear it. Or maybe you won't. That extension got disabled, it seems. Thank you, Chrome! I love you. I love you, Google Chrome. Actually, there it is. There it is. You have to highlight it.
Oh god, the file is missing. 11.1.
Yeah, so I can read chat like that. Now it's not great. I need a better way to do it. So I'll try to read chat, but because I'm doing a programming stream, I actually have to zoom into the screen and go over to the chat. I don't have a second computer on my desk right now. I have my laptop set up over there, but I can't access it right now. So, anyway. There are some problems with this build of Red Team, though. It's still using monokey. This is not OpenGL, this is monokey. And there are certain things that are broken, like the resolution select doesn't work. So like any resolution you want, it just doesn't work. It's broken. In fact, I can't even read this text because the engine has completely screwed up the way it measures text. So there are certain issues like that. Stealth mute. Oh, what the hell? I've been muted this whole time, I apologize. So what I was showing you was that the game is very much broken, but it does work. It's still in mono game, which is a problem. So we're gonna actually go in and try to port as many things over as possible. I haven't really prepared for this, but we're gonna try. The first thing that's a problem right now is if I go into Red Team. Actually, I'm right here, I can go into here. Red Team app is the application that launches when you run the game. It sets up all of the basic systems that the game uses and all that stuff, and gets you into the main loading screen type thing. This works. But if I go into the inheritance of this class, you can see that it's Game App. Game App is all mono game. All of it's mono game, and it inherits from Game App Base, which is even more mono game. You can see right there, mono game loop. Yeah, that's not great. So somehow we need to take this app and move it over to the new Game App Base, which, if I go Thundershock, or if it's, I think it's in repeating music. Why is it repeating music? I have a macro to fix that. There we go. We have two game apps that we can use. We have new game app base, which I believe is based on graphical app base. Yeah. So this is new game app base. Graphical app base should be internal, actually. So this is what we need to somehow get the game to inherit from. Now, it's not exactly as trivial as you'd think. See, I could go in and go into Red Team app and just say, hey, instead of this being game app, it's a new game app base. But, first of all, on post-init, we can't override that. On load, or on init, can't override that. On load, can't override that. And we can't load scenes, we can't do any of that stuff right now. That's a problem. I can fix most of the app loading issues and stuff like that fairly easily. What we need to do is... let me think for a sec here. The graphical app base takes care of the run loop and everything. This should be internal, but it does take care of the run loop. As you can see, there's Bootstrap. This is for actually launching the run loop and everything. There are many hooks that we need to add into this, that are fairly important. Like, there's pre-init right here, and there's on pre-init. So we're gonna add a few more of these here. We need a protected virtual void on init. And we need an on post init. I see that the music is very profane this time around. But there's our engine initialization hooks all set up there. We of course need to call them. So the way we do that is inside the Bootstrap. We have the pre-init, which is basically working. Init is gonna come after the renderer has... Actually, this is a renderer 2D, so it's not even... We don't need that. We can get rid of that in here. We also don't need this font. That can go. Run loop is actually going to take care of init and post init. So we're gonna go into run loop, and we're gonna call...
I'm gonna get you.
First of all, we have a protection matrix that doesn't need to be here. We're loading in some resources that we don't need to. We are loading more resources that we don't need to. And we're gonna call an init method here. That's in ATK, we definitely don't want to do that. GNOME Toolkit is not what we're using. But there is private void init. I'm gonna make that private so that we can't call it outside of this class, but all it does is calls on init for now. We might do things later on, like set up an ECS and other engine-level systems, but for now, that's all we need the init method to do. And, of course, we need to call post init. Which, of course, for now calls on post init. Now for this, of course we're running a game loop here, so what we need to do is set up some sort of time system so that we can track the frame time. And that's going to be important for things like physics and animation, so we're gonna set that up here. I think what I can do is I can use a stopwatch to do that. It might not be a very elegant way to do it, but stopwatch, if we read the description here, provides a set of methods and properties that, I really wish I had that read aloud function in Rider, that would be kinda cool, that you can use to accurately... I really can't read this. Measure elapsed time. That's exactly what we want. We want to know the frame time, and we want to know the total game runtime. So we're gonna use a stopwatch for that. I'm gonna call it frame time, or frame timer. Now, I'm not sure how we're gonna use this exactly. I think I'm gonna call that in post and set up the frame timer in there. So that's gonna be a frame timer dot start. And inside here we need to figure out how much time has elapsed since the last frame, which would be frame timer dot... So elapsed is the total frame time, or total game time. So total elapsed time measured by the current instance. Okay. There's elapsed milliseconds if we wanted that. There's elapsed ticks. We could reset the timer, we could restart the timer. There's a lot of stuff we could do. We can stop it, we can do all the UL.NET object stuff. We really only care about elapsed time. So I'm gonna create two new variables. Frame time equals, actually bar frame time equals frame timer dot elapsed. And what I need is I need to track the total time so that I can get a delta value. So in here I'm going to create a new time span. Whoops. Total game time. Alright, so now we have the ability to do a delta check. So the way we do that is we get our current frame time. Actually I'm gonna call this game time. And I'm gonna call this variable frame time, which is simply gonna be game time minus total game time. And then we're gonna update total game time to be game time, or to be game time. Actually, we're gonna do that at the end of the loop, just in case something crashes, or something like that. Alright, so we have our delta time, and we have our total frame time, that's cool. Let's create a new game time object so that we can keep track of that. And this is a Thundershock object, this is not monogame, so we have to give it the elapsed time and we have to give it the total time. We have that data. So we have frame time and game time. That creates us our new game time object, which is what we're gonna pass around. I'm gonna call this game time info. This is what we're gonna pass around to our scene system and our ECS and all that stuff. This projection matrix we're gonna get rid of. We're going to leave the graphics device clear. It clears the screen to black. And then what we're gonna do is we're gonna bank off of monogame loop. I'm gonna use that whole entire system to create a game loop class that we can update from within our app. So what I'm gonna do is inside of Thundershock, now I'm just also gonna look over to see chat and there's nothing new, okay? Let me think. Inside Thundershock, we have a monogame loop, but we also need a new game loop. So I'm gonna create that. And it's gonna be internal. And sealed. And it's gonna take a graphical app base and call that app. So then we're gonna do public game loop graphical app base app. And I'm not gonna do a null check just because this is internal. I might do that later on, but for the sake of brevity, we don't need one right now. We know that the app is gonna be valid. So this is gonna take in an update method. Or this is gonna have an update method, sorry. And it's going to have a render method. And it's gonna take in our graphics device. No, not graphics device, graphics processor. There's a graphics processor, so that's gonna give us the ability to render things to the screen using the graphics processor. Actually, that might be a bad idea to pass that directly into the render method. Instead, we're gonna take in a game window. Alright, so that gives us access to our graphics card through the game window, which is better. That way the game window takes care of that for us. So I just want to make sure that I'm not using any Microsoft XNA framework crap. Thundershock.core, that's what we want. No mono game, not allowed. Not allowed. That's good. I'm going to have that be created by Graphical App Base. Alright, there's game. And that's gonna be created by init. So that's where we're gonna do that. We're gonna create this before calling on init. And all it does is it takes this, and the game window.
Welcome to your new sanctuary.
And all we're gonna do is, so GameWindow.update, that's what's gonna actually update our input system and get that all set up. And then total game time, of course, that's fine. This is also gonna swap our OpenGL buffers. So this we need to call here. But as far as the render loop is concerned, all we need to do is game.update, pass in our game time info, and then game.render, pass in our game time info. The game loop's gonna take care of the entire render pipeline and making that all work. Now with that said, now we need to worry about the scene system. Because, well, if we go back to Red Team app,
For your fucking life.
if we go in here, first of all, this needs to be an on pre-init. Which should be overrideable now. But yeah, there's, on init, that's doable. We don't have an onload method yet, we're gonna add that. Let's actually add that right now, the onload method. That's gonna happen after our packfs and everything is set up, but for now we don't have a packfs to set up, so we're just gonna call it right after calling on, or posting it. So, wait, this is a hook, so it has to go at the bottom, that's my convention. It might be a good idea to call that in new game app base, not in graphical app base. So we're gonna do that instead. We're gonna have that called by posting it. So let's see where we can find new game app base. It's a little hard to traverse this code base right now because some of it's new and some of it's old and gonna be removed. So apply config. So inside on posting it, we're gonna call based on posting it, but we're also gonna call on load. So that's where you load in your scene and all that stuff. That's what onload is for, or is for. That's for loading in all of your content and your scene. Which means there's now a problem. We don't want anything overriding this. So we're gonna make this a sealed override method. That means that we can still... That means that this class is still something we can override, but... Actually, this needs to be an abstract class. but we can't override that specific method. This is sealed, you can't touch it. Which is a problem for Red Team app now, because we override the post-init method. Actually, no, we don't. We only override the on-init and on pre-init, so that's okay. That's okay. Onload is gonna work, but we still have load scene that's missing. So we're gonna add that. That's gonna be in graphical app base. And the reason for that is that our scene system is not unique to games. We might still use it in, say, a content editor. So we're gonna go into graphical app base here. Wherever it is. And I need a load scene method. And in fact, I'm gonna actually make that method protected, because you're gonna use this scene class itself to trigger a load event. Or a scene component, or no, a game component, not game component, I'm thinking of our old system, but when we get to an ECS, that whole system is gonna be overloaded and overridden. The scene system is gonna stay the same, but we're gonna have game objects and we're gonna have game components, and of course, systems, but you'll be able to load a scene from within a scene or game object. Or, actually no, not game object. My mind is all over the place right now. I'm trying to conceptualize in my head what an ECS is before I've even implemented one, and I'm trying to figure out how this API is going to be architected. We're not going to worry about that right now. We're not going to go that far in this stream, so forget about that. Forget about ECS and all that. But we're gonna have a facility to load scenes and stuff like that, but it's not gonna be as part of our app. You're not gonna be able to call directly into this app load scene method. But we're gonna have this method as protected that our app itself can load in a scene, but nothing outside the app, other than a scene itself can. And we're gonna add some type constraints here. We need the type that we're being given to be. It needs to inherit from scene, which is a class that we have in the monogame SDK. And we need it to be constructible. So that's what new does. Anything else we're not allowed to do. So what we're gonna do is we're going to pass that along to our game loop. Alright, and that's a red method. That's Ryder telling us that, hey, stupid, that method doesn't exist, so we're about to add that method. And of course, since this method is being called by a templated method with constraints, we need those same constraints applied here. So it needs to inherit from a scene, and it needs to be constructible. Alright. Tobias says, app, Are you trying to make me sound like Justin Trudeau there? The joke is that Justin Trudeau says, like every single word, and, I'm, very, bad, for, that, so... But, yeah. Okay, that might go into an end of year clip reel right there. Anyway. Oh god. It's now incredibly hard for me to avoid saying, Anyway, what we're gonna do is we're gonna create the scene inside here. So var scene equals new t. And we're gonna pass this along to a load scene infernal method. Alright, and then that's gonna be a private method, so private void load scene internal. Alright. And the reason I'm splitting this off is because I might have extra behavior that I want to add here eventually, but I don't want to deal with messing up with the actual loading routine. And what for example, I might add a system whereby you can fade between scenes, where it'll take the last frame rendered by a scene, cache it into a render target, and display that with a fade animation as it loads into the new scene. For that to work, I might need to add a new overload to this method, and I still want to be able to load the scene internally, with the load scene internal method. So what we're gonna do is we're gonna have a private scene current scene. And this is where things are gonna get kind of annoying, because scene is a monogame class. So we can call things like onload and oninit and all that stuff. We shouldn't, but we can't render the scene yet, so we won't be able to see anything. But that's okay. All we're gonna do is we're going to check if current scene is not equal to null, and if that's the case, we're gonna unload the scene. So what that's gonna do is it's going to call, or first of all, we're gonna do another null check. And if it's not null, we're gonna do current scene dot unload. That's gonna unload all of the components and all of the entities and stuff like that later on. And then we're gonna set it to null. And then what we're gonna do is we're gonna set current scene to be seen. And that's going to happen after we've actually initialized the scene. By doing load. So that loads the scene in, and then it sets it as our current. And then under update, this is where things get quite annoying, because, again, we are going to be switching to an ECS eventually. But inside here, what we're going to do is we're going to check if current scene is not equal to null. And if it is, then we're going to call, or if that's the case, we're going to call on, or update on the scene, and pass in our game time. And we might notice a problem. As you can see, Ryder is underlining game time as red. That's because, if we go into this method, you can see that it does take a game time, but it's a monogame game time. So that's not good. There's a way to fix that, though. What we do, and this is gonna spread like a virus throughout the entire scene system, so what we need to do is, because we're still using monogame, we still need the Microsoft.exe framework stuff. But we can get away for now with doing a using game time equals Thundershock.core. Thundershock.core.gametime. And that's gonna fix the issues. For now. We're gonna remove that eventually, but it's gonna at least get rid of the underlined game time here. Now, if we compile, we're gonna run into quite a lot of issues. GameLoop.cs. There is no argument given that corresponds to the required formal parameter app in scene.load. And that's not good. We really don't want access to our app directly like that. I mean, it might be a good idea to, but ideally we would give it the game loop and it would take care of that for us. So we need to give it a game loop. Luckily, this is a game loop. Now, it's not a compatible type, so we need to go in and change it. And again, this stuff is going to spread like a virus through the entire app system. Which I'm not too thrilled about. But as you can see, there's a problem here where this is a massive API issue in Thundershock, the old version of it. We're passing in an app base and a monogame loop. Wouldn't it be great if we passed in the game loop? That's what we're gonna do. We're gonna pass in our game loop, and we're going to get rid of the app. We don't need it. We don't need it. You can go away. And then this is an incompatible type, so we're gonna go in here and make sure that this is set to game loop, not monogame loop. Alright. So game loop is being set properly. App, we're gonna get rid of. We really don't need the app being referenced directly by the scene. The whole point of the game loop is to abstract that away for us. So, this is going to go ahead and kill that. And there are some components being added here. Oh yeah, this is the component loader. This is for the old component system that's now obsolete once we get an ECS into here, which I'm gonna do after the stream. ECSs are very hard to implement, and it's a new concept for me, so it's something that I don't want to do live, whereas this is a lot easier to work with. Now we're having a problem here where the components now take a monogame game time, which we need to fix. Again, this is really gonna spread like a virus throughout the entire engine, and it's kind of annoying, but we will get it working. Alright, so let's see how we have this set up here. There's gonna be even more errors, oh my god. All of the game systems have completely killed themselves. Backdrop.cs now takes a monogame loop. Now ideally you wouldn't have components drawing like this. That would be done by an ECS. What you would do in this case is you would have an entity. That's like your backdrop entity. And then that entity would be composed of like a texture and a transform. And then, over in the game loop land, what we would do is we would look for all entities with a texture and a transform and say, hey, let's render those to the screen. Something like that. That's what an ECS is, and that's what we're going to implement after the stream. This system right here is a little more logical for a developer of a game, because it's, you know, it's a backdrop. It inherits from scene component. That implies that we can add it to our scene. But this is very bad for performance, very bad for engine architecture, so it's obsolete. We're going to add a different type of system for this. And this type of refactoring is why this type of system is bad, because now that we've gone ahead and we've changed what our game time class is to our own engine implementation rather than monogame, now we need to go into all these different components and say, hey, your update method now takes a Thundershock at core.gameTime. I'm very caffeinated now. And that's annoying. An ECS would totally get rid of that. Alright. So now we need to go through all these different UI elements, or not UI elements, these scene components, and fix them. And I really don't like this. I hate that we use this system. I don't know why I didn't learn ECSs earlier. Now, to make this a little easier, I'm going to copy-paste it. Warning printer. This is not something I enjoy having. This is for the debug console. Ideally, we wouldn't have to do this. If we had an ECS, we could just say, hey, logger, can you please log to me? And, like, have the debug console completely separate from the scene system. But I'm a stupid programmer, and I fricked up my entire component system in Thundershock. So... But yeah, this is an example of what would be a component in an ECS. This would be a sprite component. You would add it to your entity, and then the 2D renderer would go in and render that sprite for you. Developer console would be a system, not an entity or component. Vorbis player, this would be a component. You would attach it to an entity and then it would play a sound. And it would feed it into the sound system. Which we don't have. We don't actually have a sound system in this current build of Thundershock. GUI system, this would be a system. And then your GUI elements, they would be either entities or components. I actually don't know. I would probably make them entities. Yeah, we're running into even more issues now. Now, element.update takes in... Yeah, this is gonna spread like crazy. Ah. Alright. As you can see, the new game time class is now spreading through every inch of the game engine, and it's... You can see that it's starting to become very, very frustrating very fast. On Paint, this is not supposed to be... It really doesn't need to take game time. There's not a single UI element that ever uses game time in its Paint method. Now, the end goal of this should be that, Red Team should crash. It should try to launch, but it should crash. And it'll crash because the monogame content manager doesn't exist. And we have a fix for that coming. Alright, gonna chat. Oh my god, you guys have been talking a lot. So I'm gonna take a break to read this. I think this is Danish text, and I can't read Danish. Let's see how the, text-to-speech fares with it.
Nu undrer jeg mig lidt over, hvordan det vil lyde, hvis du udtaler det her.
Why do I have a dedicated... why do I have a dedicated class for printing? Okay, so the thing with warning printer is... I had to pause my music for a sec to hear what that was saying. Warning printer is a weird name for just the temporary log, because in Pandemic Framework and in Thundershock, if there's ever an error or a warning in a debug build, it will print it to the game screen. Now, that's what warning printer does. It's a weird name. It's just a temporary dev console. So yeah, that's weird. It's one of those things that if this were an ECS, that class wouldn't need to exist. So eventually we will fix that. We will get rid of it, but that's gonna happen off-stream because, again, an ECS is difficult to implement. It's a strange concept when you're new to game engine development. It makes sense when you learn the theory behind it, but it's really, really strange. Why is this red? The using directive. Oh, I see, because this one's explicitly saying that game time is from monogame. Alright, we don't need that. Actually, this uses more Thundershock core things than monogame things. That's impressive. Alright, I'm slowly killing all these errors. They're all GUI system errors at this point. What does console control inherit from that requires... What? Game time is an ambiguous reference. What? I explicitly defined the the type up here. Wait. No, I didn't. Okay, never mind. I'm dumb. String list, that's your ordinary WinForm style list box, by the way. Don't know why that has a game time in it. There's no animation. Text entry, why does... Okay, that would actually make sense. That would flash the text cursor, but that would be done by the GUI system. But as you can see, we've fixed all the GUI errors. Now, game app base app, this is... For compatibility, I'm going to expose the, game loops app property. Now, of course, later on, we won't want this. And of course, there's not even the property there to begin with, so we're gonna have to add it. But for compatibility's sake, for now, we're gonna have that. We're gonna have an app property that we can access. Whoops. Why did that import SDL stuff? That was weird. That was strange. That should not have done that. Now this is a problem. This needs to be a graphical app base. And of course, monogame loop. I don't think there's anything inside Thundershock that actually uses the game loop property anymore. Other than scene component, apparently. That's okay, we can move that over. Oh god, this is starting to become insane. So this is font stuff. This is why I hate the warning printer class. I'm going to get rid of the warning printer class. Axe it, we don't need it. Kill it. Murder it. Debugging warning printer. Delete. Funny how like 17 errors went away the moment I did that. Okay, so where do we load in the warning printer? Because I'm gonna have to remove it. We load it in here. Yeah, this entire thing is dumb. We're gonna get rid of the dev console for now. I'm probably gonna rewrite the dev console anyway. It's a little crappy right now and it barely works. So I'm gonna remove the dev console completely from the engine for now. That's gonna save us a lot of time. You can't really do anything with it. So now monogame loop is... it's... broken. Yeah... a lot of stuff is gonna break now, so we're gonna go ahead and we're gonna make this method do absolutely nothing. It is now a stub. And this monogame loop, game loop, this needs to be as the game loop. And... what? Does the scene not expose that property anymore? Did I delete it? I don't think we need it. We don't need it. No, text component, what does... I'm going to add a new font system to the engine. Or, I've already added a new font system. Now, we're using sprite fonts in this class. This is something that we can easily port over. Instead of using sprite font, we're gonna simply use a font from Thundershock.core. And of course, this is gonna have its own type as well. And then, so Thundershock.core.font, that's what we're going to use for fonts in this. And of course it's going to break the renderer, but that's fine. Font, by default, is going to be font.getDefaultFont. That's a method that doesn't exist, but we're going to write it. This is going to pull a TTF file that's built into Thundershock.core and load it in for us. Now that's not desirable. You would like to use your own font, but this is gonna work. This is gonna be a lot better than having to build it into content pipeline. Oh my god. So we're gonna go into the font class, and this is an abstract class, so that's fine, but what we do is, first of all, we're gonna move this render helpers class into its own file. And I'm going to create that default, or get default font method. And actually, it needs to take in a... I actually don't know if it needs to take in a graphics processor, to be quite honest with you. Actually, it does. It does. It needs a GPU. What this is going to do is it's going to do, or if resource.getStream type of font dot assembly, and the ID is going to be Thundershock.core.builtin font.ttf, and this is going to give us a resource stream, so outstream stream. And if this returns true, we're going to do return from ETF stream. I'm going to pass in the APU and the stream. Steam? Steam? The hell are you doing here, buddy? I don't want to play games right now, I want to make games! Alright, and then otherwise we're gonna throw a new invalid operation exception. Actually, this is gonna be a debug assert. Yeah, debug asserts are great for operations that you definitely don't expect to happen in a release build. Actually, we're gonna do a var result equals false. Whoops, that was weird. What did I do? Oh god, where's the curly brace? Get back here, buddy! Why are there two? Ugh. Okay. Result is gonna become true in this case, and then at the end of this we're gonna do a debug.assert on that result. And the message is gonna be couldn't find built-in engine font resource. We will trigger that assert when we actually start doing things with the with the game. Where's the error here? So this is gonna return null. text component, of course, color is an ambiguous reference between Microsoft.xna.framework and Thundershock. So what we're gonna do is we're gonna rip Microsoft.xna framework right out of the equation. We have a color structure. What we don't have is z-vector2, that's in system.numerics, so system.numerics, that's our vector2 class. Alright, so that fixes a lot of the errors with that. Now, on load. I don't like that we have to do this. This is why I really want an ECS in the engine. But this is going to go ahead and load in our wait, what? That's showing as a static property access. Scene.graphics, that's what we want. Now, I don't like that I'm exposing the graphics processor directly through the scene. Again, that's what we would use an ECS for, but... we do what we gotta do. So, we're gonna expose... we have to do what we have to do to get this thing compiling and working. Eventually I can go in and I can refactor this entire thing to not require this nonsense. So graphics is gonna be equal to GameLoop.graphics. And of course, this is the monogame way of doing things. I hate it. I don't like this. When we get an asset manager in, we're not gonna need any of this code, trust me. The asset manager is gonna have access to the graphics processor, so it can do graphical stuff. But the way we expose this is we do public graphics processor, graphics, and it's gonna return game window. What? Oh. Game loop. Wait. Where am I? I'm an idiot. I'm still in the scene class. I want to be in the game loop class. Alright, so graphics, processor, oh, whoa. Bring that type in. Graphics is equal to, or it's gonna return the GameWindow.graphics processor. There, we've exposed it. Now, I don't like that we exposed it, but we have exposed it. We have even more errors in the text component, because we're trying to pass a Thundershock font. Actually, this is... What are we even doing here? We're passing a lot of stuff from Thundershock into monogame, and it's getting confused now. Yeah, what happened is, I think... we're mixing monogame vectors with... I'm gonna make this a stub for now. Now, I'm not gonna totally make it a stub. I'm just gonna comment out all of the code. We'll implement that later. GUI system. Debug font. Instead of trying to load a font from monogame, we're gonna use that same font.getDefaultFont. Really? Where are you getting font? Is it or is it trying to bring in, like... Oh, it's bringing in Pango. I really need a better way of doing platform-specific GUI stuff, because I'm using ATK Sharp to get Linux dialog boxes and stuff like that. It's a NuGet packet, and it, like, tries to infect my IntelliSense like this, and it's really annoying. Like, I don't want a Pango font, I want a Thundershock font. Like, just let me do that. Okay, please? And of course, debug font needs to be a font. Ooh, more errors with monogame loop. That's great. We're not gonna update the scene, and we're definitely not gonna update the app. Don't do that! There, we don't need this update method. We've made it a stub, and it's an override method, so it doesn't need to exist. This should not be a sprite font. It should be a font. Alright, this is spreading like a virus! I don't... Why did I decide this to be the stream? Why? Like, I'm doing sprite font stuff, and... This is gonna take me hours upon hours to get all ported over. Ugh! I forgot how complicated the GUI system is. Like, monogame is so annoying. Oh god, rectangle is an ambiguous reference between monogame and Thundershock because we have a rectangle structure that we implemented the other night for the 2D renderer, and you know what? I'm gonna axe the Microsoft.xna framework namespace in here. Get out of here, buddy. Now, what is Vector 2? That's something we want from system.numerics, and yeah. Now, luckily, the GUI style system takes a Gui Renderer for all of its rendering functions, so this is going to be trivial to port over. We just need to have Gui Renderer take in a normal Thundershock 2D renderer, because GUIs are going to be 2D. Now, it could also take a render to texture renderer, so you could do fancy stuff with 3D GUIs, but this should not be a sprite font. Why is this a sprite font? Why is any of this monogame? Why didn't I start out learning OpenGL instead of monogame when I was younger? See, monogame is great for small games, but don't write a game engine in it, please. Save the sanity. Because eventually you're gonna run into certain issues with it. Why is this using ATK? I hate that ATK is used by Thundershock. Oh yeah, this also needs to take system.numerics. Oh, look at that. All of this stuff is broken now. Okay. This is easy to fix. Font.get font. This needs to return a font, not a sprite font. Oh yeah, I'll have the GUI rendering stuff ported over in no time. I basically need to replace all of these instances with... or all of these sprite font instances with font instances, because font is a more abstracted class. It could be a sprite font, it could be a font/sharp font, it could be a ADI font, it doesn't matter what it is as long as it's a font. That's kind of what we're going for right now with this new API. So, to fix this, we need to get rid of the Microsoft X Native framework and do Thundershock.core. There we go. Small problem. Color.gray does not exist. Now, colors are kind of annoying thing. Kind of annoying to deal with in C#. See, with system.drawing.color and monogame's color, we have a massive list of, like, all of these named colors. So if I do using ADI color equals system.drawing.color, this creates a type alias. And if I go into ADI color, it's gonna bring me into the type alias definition. If I decompile this, and I'm okay with decompiling it because it's an open source project anyway, .NET Core is open source. This has a whole bunch of stuff in here, all of these different named colors, and there are solutions to this, like we could have... I could generate this list. But I really don't want to. Known color. What is known color? Yeah. Monogame has it too, like I could decompile their color structure and we'll see the same thing. I'm actually curious to see what they do with it. I'm trying to avoid copying code from Monogame, because Monogame's license is kind of not very permissive in how you use it. So if I decompile this, yeah, they are basically... they have a static constructor that's going ahead and constructing all of those objects, so... yeah, why aren't they using a hexadecimal literal here? Why? So yeah, all of these named colors, basically what I need to do is I need to generate them on the fly, or generate them not on the fly, but... I don't know how I'm gonna deal with colors. It's a very complicated problem that we're running into, and you know what? What I'm gonna do for color.gray, because I know what gray is, I'm simply gonna go ahead and add it as a property here. And gray is gonna be OX7F, OX7F, and OX7F, and the alpha panel is gonna be implied. I just realized I typed in an F7 there. And actually it might be 80, not 7F. Now, I might actually write a tool that lets me generate all of that for me, based on system.drawing to color, but... Actually, yeah, I could do that. I could write a .NET tool to do that, to generate a color list. But then we're running into another issue where the GUI renderer now takes in monogame stuff, so we're gonna fix that real quick. So I'm going to take this system.diagnostics and I'm going to replace that with system.numerics, because I know I will need it. Microsoft.xna framework is going to be Thundershock.core. Microsoft.xna.framework.rendering is going to become Thundershock.core.rendering. That's where we get our 2D renderer from. And I don't need Thundershock.rendering. And this is going to be a renderer 2D. I just realized I already use a custom renderer class inside the monogame version of this. So this is really going to be trivial to get rendering working. Yeah, there's sprite effects. We don't need those. We don't use those in Thundershock. They're not a thing that exists. So... sprite batch.fill rectangle rect.location.toVector2. What is this even? This is taking in a texture and a color. We have a method for that. Get render tint, that's normal. And then it just takes in the texture, and then we don't care about effects. There, that's redundant. I think there's another fill rectangle method that does the exact same thing in this class, so it's probably redundant. I think these are what the errors for that are. Actually no, this is drawstring. Alright. This can take in a font. And I think the API is the exact same, so this is great. Yep, monogame loop now cannot create a renderer because it's not. Yeah, okay. Get rid of draw. This is all the post-processor stuff. That's something else we're gonna have to port over soon. GUI style, what is this rendering now? Ooh, bounding box is probably a Microsoft.xna.framework.rectangle, and that's not good. But at least we're no longer using Microsoft.xna.framework.graphics, so we could probably go in and just remove that. Let's see if that works. Oh, we're missing our our system.numerics. Okay. I'm using system.numerics for all of my vector classes because they're already implemented. All the math is done for us by .NET Core. And they're fast. And, you know, it's a built-in framework library. Why reinvent the wheel? So that's pretty cool. Element, what is going on here? Okay, now it's all using Microsoft.xna framework. Kill it, kill it, kill it. This doesn't use system.numerics. Okay. Now, what is it complaining about here? think this might be using XNA framework. Yep. Anytime you see Microsoft.xna.framework, we're gonna replace it with Thundershock.core. Alright, numerics and Thundershock.core are added there. Yeah, there's a lot of stuff we'll have to add. Actually, not really. This is pretty trivial so far. Get rid of ATK, we don't need it. Add our system.numerics and Thundershock.core. Actually, it looks like system.numerics is not used in this case, okay. Free panel, this is what we use for the actual GUI root element. This allows you to place an element anywhere on the UI. Fun fact. Vector 2 should be system.numerics, and Microsoft.xna.framework should be Thundershock.core. That was weird. I don't know what Ryder did there earlier. Button.cs. Alright, menu.cs. This is a fun one. This is one that I'm working on. It's a work in progress element, but this allows you to create, you know, it allows you to do this in Thundershock. You know, with your file edit, view, and all that stuff, that's what this whole thing is for. So that's coming in the new version of Thundershock, the ability to create those menus. Menu bar is the same thing, it's actually the horizontal version of menu, so... Again, it's a work in progress, but we're getting there. Alright. Scroll panel is our vertical scroll UI, so that's nothing new. Alright, picture is this is our equivalent of a picture box in WinForms. Why it had system.reflection being used, I have no idea. Why it has... Oh, I guess for textures it would have that. So Thundershock.core. Whoops. I think texture is in Thundershock.core.rendering. Now, if we had an ECS, this would not be used directly. You would go ahead and you would use, sprite effects. Why is this a property? We don't need that. You would go ahead and use some sort of texture component, and that would take care of your, image rendering. Actually, for a GUI element, I don't think I would use an ECS for that. I would let the GUI system completely take care of UI. However, I would use an ECS to allow the GUI system to render. That would be something that I do. Alright, I'm gonna take a moment to read chat. This stream is very much exhilarating. Actually, I know that it's not very visual to you guys. I know that. But Thundershock is something that's very important to me. The fact that it is this far along, as far as being an OpenGL game engine rather than a monogame game engine. Now I know I'm in the middle of making it work properly. Doesn't compile right now, but the fact that it's gone this far that I can actually go in and, you know, move all of these monogame dependent, monogame heavy classes over and make them non-monogamous, which is my funny way of saying not using monogame. The fact that I can do that and it's just gonna, like, for the most part, slide in and work in place. I mean, content pipeline's not gonna work, but I'm prepared for that. I don't want to use content pipeline, but the rendering system's gonna work. Font system's gonna work. GUI styling system's gonna work. It's all gonna work. As long as I change some using statements around in C#. The fact that we've gotten that far along with moving the engine over in 5 days, when 5 days ago I didn't even know how to use OpenGL. That's pretty fucking awesome. And I really want to show you guys just how simple it is to get this working. It's time consuming, but it's really not that hard. And so this takes in a sprite, or this returns a sprite font, which we don't want. So that fixes that right away. Some of these text-based elements are going to have that method that takes any weird, or that returns a sprite font directly. That's for compatibility's sake. Really don't want it there. But, oh well. Item list element, I think it's missing our, yeah, it needs our system.numerics. It needs our Thundershock.core. I don't think the input system's gonna work at all, though. That's something that we're gonna miss out on until I get that working. Alright, wrap panel. There's a lot of using statements in here that aren't being used. Oh my god. I think I was using Visual Studio when I wrote this. Alright, text block. There's another case of... Okay, so this has a system.numerics in it, and not a Thundershock.core. Alright, so that fixes text block on all the weird usings in it. Wrap panel.csy. What's going on here? You have your system.numerics. Where am I screwing up here? There's something weird going on, and I don't know what's causing this issue, but for some reason it doesn't think that this vector 2 is the same as the other vector 2. Ambiguous reference between Microsoft.xna.framework.vector2 and system.numerics.vector2. But we're not using Microsoft. Oh wait, there it is. That was weird. Alright, text block.cs. You are also returning a sprite font. It's not good. This should no longer be a part of the, text block class, but it is for compatibility. This should be in its own Thundershock.core class, all the text wrapping stuff. I will move it eventually. I think we've moved all the UI elements over. Whoops, didn't want to do that. Alright, what's text entry doing now? Alright. Now, what are we missing here? We have basic style.cs. Color does not contain a definition for blue. I can fix that. Blue is just OX0000FF, so we'll add that. Basic style.cs cannot implicitly convert type Microsoft.xna.framework.color to Thundershock.core.color. That means that we were still using monogaming here. What? What is even happening right now? Oh, Thundershock platform .html color. That returns a Microsoft.xna.framework.color. I'm retarded. We're gonna just go ahead and make that return a regular color, and that's gonna fix quite a lot of things. Now, are we using Microsoft.xna.framework? No, we're not. Now, I will no longer need the Thundershock.platform.html color class, because that's... we have our own color structure. We can just use the color structure to implement that. So, eventually I will. But, for now... Alright, so style color. This, I think, uses a monogame color, so that's not good. Using Thundershock.core. Fix that up right there. Oh goody, keys. This is gonna be... probably... Thundershock.core.input. And we're gonna get some ambiguous references again. Because of the key event args. Ambiguous reference between Thundershock.input and Thundershock.core.input, but that's okay. See, now we have no ambiguous references, but our element actually expects the old input events, whereas we want the newer ones. That's gonna spread to the GUI system as well. This is, yeah, now we're progressing into the input system, which is trivial to work on. This is, it already works, we just don't dispatch any events to the actual engine yet. But all the mouse input and the keyboard input stuff works. I've moved it over to the SDL window. And it's been located in, all the input event types and all that have been located, or relocated to Thundershock.core.input. The only reason we have Thundershock.input now is for compatibility with monogame, but that's not gonna matter when we actually get rid of monogame. So, I'm moving all those type references over. Now there are gonna be weird inconsistencies with the input system and how things are named, but that's okay. I know what they're named, I can fix them. Where's the input reference? It's right here. Oh, and this no longer needs to be a thing. This no longer needs to be a thing. And this no longer needs to be a thing. This using statement is implied because we're in Thundershock. This one's applied, and this one's implied as well. Thundershock.core.input. Are we using Microsoft XNA framework anywhere? We shouldn't be. We shouldn't be. And we shouldn't be. Alright. What did I break this time? Console control. Letter wrap. Ah, yes. Because that's something we need to do in the console control. Hey, the benefit of this is that we have dynamic font rendering, so I will be able to implement zooming into the terminal in Red Team. Just thought you guys should know that. Okay, this needs to be a font, not a sprite font. Or an aunt. Alright, so where are we screwing up here? Where are we using the wrong input method? Mouse button should be in. Yeah, mouse button is definitely in core. Oh wait! That's dumb. I never moved the namespace over. I'm dumb sometimes. That should fix some issues. I don't know how the hell that happened with the input. Oh god, it's... That was strange. I don't know why the mouse input code was there, but I think these are now... what's going on here? Color.darken. Darken is an extension method of color, and so is lighten. It converts it into a 8SL color and increases the luminance value of it, or decreases. I can't remember exactly where... Oh, it'd be under color helpers. What we need to do to get this working is we simply need to replace Microsoft EdX and Up Framework with Thundershock.core. And then there's going to be an 8SL color. That's also going to need to be in Thundershock.core eventually, but for now, we'll leave it as is inside of the Thundershock main library, but this will eventually be moved into Thundershock.core. It makes sense to be there. And of course, maphelper.clamp is not a thing in monogame. Or in Thundershock. Which is okay. I'm going to immediately fix that. Clamping is easy. Really easy to implement. So, what I'm going to do is inside Thundershock.core, I'm going to create a new class. I'm going to call it MapHelper. For compatibility. Eventually I can rename this. I'm going to call it MapHelper. It's going to be a static class. And what we're going to do is we're going to have a public static float clamp. And we're going to have the value. We're going to go min and max for our second parameters. Now, if the value is greater than max, we return max. If the value is less than min, we return min. Not int, min. Otherwise, we return value. That's a clamp function. Simple as that. We're a computer. We can do that. So that's gonna fix our color.darken and all that stuff. That's all gonna work. This location.toVector2, this is irrelevant. It's already a vector2. Which is great. I love that. Our rectangles are now floating point. So that's gonna fix a lot of weirdness in the UI system, for sure. But as you can see, we're logging stuff in here. Why are we logging stuff in here? But we're getting back into the scene system. So we're no longer messing with GUI stuff, we're now messing with scene stuff, and this is gonna be... Oh wait, we are messing with GUI stuff. Cyan is an easy color to add to the list of colors that we know. It's just full green and full blue. That's cyan. There's our cyan colors. That'll fix that. That was just a missing definition. We're gonna run into that every now and then with our colors and stuff like that, but we'll fix it as we go. Rectangle bounding box. Root element dot bounding box. Root element. What does this... Wait. GUI system needs to be updated because it thinks that game time is from Thundershock.core, which is, yeah, that's what it expects. Rectangle is also from Thundershock.core. Color is not from Thundershock. Yeah. Basically, This entire thing is all messed up. I'm gonna add the Thundershock core. Oh, it's already implicitly added. Okay. Okay. Now we're gonna run into an issue here, because it's gonna try to add the, or try to talk to the input system that at this point does not exist. So, yeah. Renderer. This needs to be a renderer 2D. Provided I could actually type. And renderer 2D is gonna come from Thundershock core rendering. So we'll add that. But we have a problem because our onDraw method actually comes from our scene component class. And that is still using the old rendering system. So we're gonna have to go in and update that. Luckily, this shouldn't cause too much problems. It would have caused problems if I were using Sprite Batch, but since I'm using Renderer 2D, or Renderer, and it's a similar API to what we had before, we basically just have to do what we've been doing this whole time and just move type definitions over. So backdrop, it's gonna try to render with the old renderer. We don't want that. We're ready to remove the Microsoft.xna.framework dependencies. Oh my god! Yay! Texture 2D, I believe that also comes from rendering. There we go. Yep. Alright. Solid rectangle. Let's get that working. What are we missing here? Oh yeah, this still uses the old, or this uses the 3D renderer because I've moved it to Thundershock.core.rendering, and that's not good. There is actually a 3D renderer in this, but it's very work in progress and barely works. The 2D renderer uses it behind the scenes, but the 2D renderer also knows what it's doing because it's the Pandemic Framework 2D renderer, so yeah, this is basically going to be trivial to implement and get moved over. When we boot up Red Team, after we've moved all of the content and all that stuff over, you're going to notice that it's going to look the exact same. It's really going to be no difference. We're going to miss our post-processor because that's not implemented yet, but Red Team's going to look the exact same. There's gonna be no upgrade to it. It's just that it's gonna have a better backend. That's the whole point of this. Right, using system.numerics, Thundershock.core, and Thundershock.core.rendering. That type is fixed. What is this? Input manager. Don't worry about the input manager right now. We will implement that later. Backdrop. Batch. Viewport bounds. That's not implemented yet. So this is gonna have to be commented out for now. Viewport bounds aren't really something we can get at just yet. It's a little annoying to set that up, but I will... We won't really need that property once we get the ECS implemented later on in the engine's lifecycle, so I'm not too bothered by that. So basically I'm going to comment out all of these draw calls and all that stuff, for now. I think GUI system uses that as well. app.getComponentInput. We're gonna go ahead and ignore all of the input stuff. So get rid of that. Actually, no, don't. We're gonna want to comment this instead. There we go. And likewise, you're going to want to comment this all out here. If anybody knows the keyboard shortcut to do this quickly in Rider, please let me know. I will set up a macro for it. Proceeds to look at the chat to see if anybody answers. There's a logger call, so we're gonna get rid of that. Debug font. Why is this being loaded in the... Wait, what? Where are we? This is the scene. Okay. Alright, I can accept there being a debug font load in here, because the scene is gonna take care of our ECS and stuff like that. And if there's no camera active in the scene, we need to be able to display that to the user as a warning. Old Thundershock did that, so we're gonna retain that. Of course! Frickin' Pango managed to find its way into my source code. Go away, Pango. I don't want you. You can die. You're great for ATK, but you're not what I want. Just let me have my Thundershock dot frickin' core, please. Alright. And of course this is gonna take a sprite font as the default, or as the type, so we're gonna fix that. Now, there's a whole load of Microsoft.x&A.framework stuff here, so get rid of that, get rid of that, get rid of that. Get rid of the components. Get rid of debugging. Core rendering, we're using that. We don't need the... Alright. Why is camera... Oh, yep, okay. That's gonna be moved into core eventually. We're almost actually done. As far as moving, as far as moving Red Team over, that's gonna be a little more complicated. But as far as the engine itself, we're almost done. I say that as like 16,000 more errors come. Great! Alright, camera.viewport bounds. I'm going to need to move this over to to Thundershock.core as well. The using statements, because it uses monogame rectangles and monogame matrices, and that's not good. Alright, system.numerics, and the reason I want system.numerics is because matrix is in system.numerics. Graphics device should be a graphics processor. Also, camera shouldn't even be a class that we have to implement. It should simply be a freaking... it should be a class that we implement in our, scene system, and leave it at that. If you want an orthographic camera, you tell the camera that it needs to be orthographic. You set the viewport through the camera, and you don't do any of this stupid monogame stuff. I hate monogame right now. Like, I like the concept of monogame, but I hate its API so much. This is definitely gonna crash. I'm gonna have to rewrite a new camera system after this. Let's just return matrix.identity. This is gonna be a stub camera that I'm implementing right now, so it's gonna do absolutely nothing. I'm gonna remove this entire camera system. I'm gonna remove it, I'm gonna rewrite it. Yeah. Ooh. Keys.back. That's not a type that exists. That exists. It's backspace now. That was a weird inconsistency. Alright, so now we're getting into the weird input stuff where, wait, what? Okay, e.x and e.y, that's what they're called now. Okay, get rid of this. Get rid of this. Get rid of that. What? Yeah, this should not be a thing. We should not be creating a new instance of renderer every time. No! That's nasty! Gross! We're gonna go ahead and... Oh. That actually made me want to vomit. That we did that before. Why? Why did we do that? I mean, we need to create a renderer, or I mean, we need to create a renderer anyway, right now. Because we need something to render to. But we should not be doing that every frame! No! Don't do that every frame! Ugh. This is when we do it. Renderer equals new renderer 2D. Game loop. Dot graphics. This is a temporary solution to that problem, but it's gonna work! Alright. Let's see. This is the portion of the scene system where it says, hey, you have no camera, please give me a camera. So that's what we've just fixed here. I think the entire API is the exact same as it was in Monogame, so I think that other than the fact I had to sneeze there, that should be fine. Let's see, renderer.cs, what is this? This entire class shouldn't exist. I'm going to remove it. That's the core, that's the core rendering system. The extended rendering system, that's all here. I'm gonna remove all this. Scene component. Didn't I already set this up to use Thundershock.core? If not, I just did. Alright. This needs to be an X and a Y, not an X position and a Y position, because I'm better at naming things now. Ideally, this type of transformation should be done by the input system, but it's not. Which is annoying, so we have to do it ourselves. As for this entire if statement can go away. we're no longer using sprite fonts, we're using dynamic font rendering, so we can get away with rendering any character we damn well want. If you want to type emoji, you can try that. I don't think it'll work, but you can try it. Camera 2D, I'm gonna make this a stub. There's another X position and a Y position that needs to be changed. Console control. Alright, this is easy to fix. Wait, no, it's not easy to fix. Screw it. I won't do that on construction of the console control, I'll do that later on. What the hell is this? What's going on here? You know what, I'm gonna make it as, I'm gonna make the location be vector 2.0. It's not gonna center the text on screen, but that's fine. I can fix that later when we actually have access to the viewport information from the engine's core. Drop-down box, what is this? Activator on, mouse up. What does this use? It used the old input system, that's what's going on. Oh my god, this is getting annoying. You know what? We're gonna return the coordinates just as is. We're not gonna worry about transforming them. I will fix that later. Same down here. No transforms. Nothing. Nothing like that. Content rectangle.location .2 vector 2 can be content rectangle.location. It's a floating point rectangle now. There's an X and a Y position. Alright. I have not been paying attention to chat. I see people. Or I see messages. What's Pango? Pango is the rendering backend, I believe, that might be the text rendering or the panel rendering, I don't know, but it's some rendering utility that ATK uses, and ATK Sharp exposes it to you, and it's annoying, but it's what it is. Ooh, minimum width and minimum height. They're integers. They need to be floats. Now you may be wondering, Michael, why the hell are you making your GUI system use floating point coordinates? And that's because I can't guarantee that the coordinate system being used by the renderer is pixel-based. It could be, or maybe you have a weird camera setup whereby it's not pixel-based. I need to be able to accommodate that. Also, using floating points throughout the entire pipeline means that I don't have to do any typecasting whatsoever, which is handy. Why do I feel like there is some old input stuff going on here? Because there is. Okay. And there's probably even more old input system stuff going on in here. Alright, what's going on here? Why is this... Wait, what is this? We don't have an intersect method, which is bad. So what I need to do for this is somehow... What an intersect method does is it takes two rectangles, and it returns a third rectangle that contains the overlapping areas of the two other rectangles. So we need to implement that. First, what I will do is I will add an intersect with method. And that's fairly easy to implement. And doing the intersect method itself is a little bit more difficult. I'm rusty on that, so you'll have to give me some slack on that one, but might as well implement them both while we're here. Intersect with is easy. If rect.bottom is greater than our top, or is higher than our top location, they're not intersected. If the rectangle's right is smaller than our left, they're not intersecting. If the left is greater than our right, they're not intersecting. And if the top is greater than our bottom, they're not intersecting. If we get this far, they are intersecting. So it's a process of elimination there. So that's how we implement intersect with. That's easy. With the rectangle intersect method, we first need to check. So public static rectangle intersect. We need to check if they actually overlap. So if A dot intersects with B, then this is where we would calculate our overlap bounds. But in all other cases, we'll return rectangle that empty. Because they don't intersect, there's no intersecting area. I don't entirely remember the map to figure out the intersecting area right now, though. I've done it in Unreal Engine, but I can't remember it here. This is the situation where I will look into Monogame and see how they do it, because it's a general math algorithm. I don't think there's going to be any problem with me using their code to learn from. I don't have access to to Monogame's rectangle in this context. So let's decompile that type and see how they do it. Alright, where's intersect? Alright, there it is. So you can see that it takes in a, oh, it goes even deeper. That's annoying. Oh, this is just for C# compiler optimization stuff. What this does, it takes in rectangle A by reference, rectangle B by reference, and it's going to output the overlap rectangle. But yeah, we are right so far with we have to check if value 1 intersects with value 2. That's correct, and otherwise we just return an empty rectangle as our overlap. But how do we do this? Ooh, I see some C# compiler optimizations. Seems like they're checking the value x, or value 1. Oh yeah, I understand what they're doing here. I don't know why it's called num1, but I'm gonna call that right. What they're doing is they're checking which one has the greater right value. I can tell what that code's doing. So I'm gonna go into my rectangle class and basically implement that. Decompile to learn, don't learn to decompile. I mean, Monogame is open source, but... Alright, so... var right is going to be... the... Actually, yeah, I think it's math.min that they're using. Yep. So, var right equals math.min a.right b.right. And then what do they do with that? The x and the y is going to be the math, or the maximum of either value 1. Okay, so that's simple. Alright, so left is going to be math.max, a.left, b.left. And top is going to be math.max, a.top, b.top. Yeah, I recognize this algorithm now. Num2 is going to be the same as num1, but we're doing it in the y-coordinate, or y-axis. So, var bottom equals math.min, a.bottom, b.bottom. So what we do now is we do return new rectangle, left, top, right minus left, bottom minus top. that's our intersect rectangle, so it makes sense. As I needed the freaking existing code to remind me how this is done. So that's a very important method that we've just implemented. Then there's more 2vector2s that we don't need. Rect.size is another helper method we can implement. Or helper property, sorry. This is very easy to implement. It's just returning a vector2 containing the width and height of the rectangle. There we go. Missing a semicolon, I think. Or maybe we're not. Oh, we're missing a parenthesis. That's what's going on. I suppose I had to read my error messages. Alright, what's going on here? X position. Y position. You know when I said we were almost done? I didn't realize that we were not almost done with this. This is starting to become very grating. I really wish I had more drinks with me right about now. Just saying. Set scissor rectangle. Now that's not something I have implemented. I don't have scissoring implemented at all in my render pipeline. I didn't think about that. We're gonna come back to that. Scissor rectangles, if you don't know, they allow you to set the region on the screen where the graphics card will call objects. So what that means is if you have an object that's outside the bounds of that rectangle, it just straight up, it'll clip it, it'll cut it off. That's what Scissor Rectangle is for, and it's... I don't know how to implement it in OpenGL just yet, which is why it's not implemented yet. But it's very handy for GUIs because you have this concept of like a hierarchy of controls, and you don't want a child control rendering outside the bounds of its parent. And a scissor rectangle is going to let you do that. It's also known as a clip rectangle because it's exactly what a clip rectangle is. The idea is that anything outside the rectangle, when you try to render it, it just gets scissored away. That's very handy. But we don't have that ability just yet. Alright, so this is an object that needs to use the Thundershock.core. There we go. That fixes that. Item list element. What are you doing with the X position again? Come on, man! Stop using that old name. It's X and Y. We don't need to clarify that it's a position. We know that it's a position. Alright, here plus equals margin.size plus padding.size. Cannot apply operand or dot numerics dot rectangle or dot vector 2 and okay, I know what's going on. This is a monogame type that we need to move over. To system.numerics. I could eventually move that to Thundershock.core, but I'm going to keep it in Thundershock.GUI. It's gonna take me a while to get rid of these two vector 2 calls. I think the general performance of Thundershock is going to skyrocket just getting rid of these calls. Because if we're not constantly converting things around, we're not allocating as much RAM. And, you know, memory allocations are great to avoid. Especially in a game. Alright, Microsoft.xmini.framework, screw off. System.numerics. Sprite effects. That's something we don't need anymore. That's also something we don't need anymore. Right here. There we go. Sprite effects are gone. I don't know why they call them sprite effects. They have nothing to do with shaders. Absolutely nothing. It's literally just, do you want to flip the or do you want to flip the sprite? And no, I don't. I don't want to flip the sprite. Alright, so freaking... Here we go with the, scroll panel, there we go. Float, float, float. We're gonna run into minor issues like that as we start moving this to a floating point-based coordinate system, but that's okay. What? Get color. Get color. What does this take? It returns a Microsoft.xmini.framework.color. Ew. Not allowed. The color palette also takes a Microsoft.xmini. I think we're moving into... Red Team code. I think we're getting that far. Nah, we're not. We're not even close. Alright, we've got color definitions to add. We need red, green. We need, dark gray. We need... magenta. Yellow. Orange. Dark red. Dark green. Yeah, we need all of that stuff. Oh god. Well, green is easy. So is red. So public static color green. There's our green. Magenta is going to be, I believe, it's going to be full red and full blue. Yellow is going to be full red and full green. Orange is gonna be let's go with 80 and 80. Yeah, I think that's gonna work. Dark yellow, I think, is gonna be color, and it's gonna be full red and then 0 to 80 on green. And with that said, I need to check the time real quick. Unfortunately, we're running out of time. But I will be back later on. I will continue this stream. So, since we're out of time, I'm gonna keep the stream going tonight, and we're probably gonna continue on tomorrow. And actually, no, we're gonna continue on tomorrow, and by that point, I will have all the types converted over and stuff like that. But for now, I have to end it off. I've run out of time, and I didn't realize it went on for this long. So, I guess there's nothing more I can say other than I've been Michael. Thanks so much for watching. I'll see you guys in the next stream. I'm really sorry to cut it short like that and so abruptly, but as always, I hope you learned something. Hope you enjoyed the video. And we didn't get that much done, but I will see you guys tomorrow, and we'll continue on with this. We'll do the red team portion. But anyway, that'll do it. And I will see you guys in the next one. Thanks for watching.